Welcome everyone. Today I'm going to talk about an essential signaling pathway called type 1 interferon signaling in the human cell that fends off invading pathogens and the detrimental consequences when this pathway goes wrong. Briefly, I will introduce the different levels of the human immune system. Then we'll go on to how a cell senses invading pathogens. Next, we dive into the type 1 interferon signaling pathway. In the end, I will give you a few real-world examples on the dire consequences of a dysregulated type 1 interferon signaling. The human immune system is a complex, dynamic, and evolving network consisting of various cell types, tissues, and organs. If you think of a time when you got a common cold from exposure to certain viruses, or when you accidentally cut your finger in the kitchen, there is always a breach of the physical barriers of your body. That being said, the first line of defense is the anatomical and the physiological barriers like the skin, the cilia in the lungs that move in sync to propel mucus-containing pathogens or other particles, the low pH in the stomach, or the lysozyme in tears and saliva that could digest certain bacteria. As you can assume, the first level of defense is pretty easy to breach, if we take skin for instance. Then, the next level of the immune system kicks in. Innate immune system comprises several types of innate immune cells and proteins. They generally work very fast in order to control an infection because they do not require further programming. The cells do not need to go through an education phase to get used to the pathogens because they recognize the common features shared among different groups of pathogens. If an infection grows out of control and the innate immune system runs out of options, it will call for reinforcements. The adaptive immune system, which can be further classified into cellular and humoral immunity. Cellular immunity gives us T cells, which either fights directly infected cells or help other immune cells enhance or regulate their functions, and B cells, which secrete antibodies that constitute the humoral immunity. Another impressive aspect is that the adaptive immune system can be taught and remember the features of a certain pathogen so that in the next round of attack, a much quicker and more significant defense can be mounted. And our topic today, type 1 interferon signaling, is one of the most important parts of the innate immune system. To initiate a type 1 interferon signaling, the interferon molecules must be produced first. There are several pathways in the human cell that can produce interferons after encounter of a pathogen. Usually, the cell senses the nucleic acids from pathogens because they're so different from our own nucleic acids. For RNA sensors, there are RIG-I and MDA5, which utilize adapter protein MAVs, and NLRP1, 3, 6, which later assemble the inflammasomes. Toll-like receptors, which signal through MYD88, and others like PRK and OAS, which function through translation repression. For sensing DNA, the cells use cGAS-STING pathway, TLR9 or AIM2 inflammasomes to initiate the expression of type 1 interferons and pro-inflammatory cytokines like IL-1B and TNF. After interferon molecules are produced and secreted outside the cell, they bind to the cell surface receptors composed of INFLANET and INFLANET2 subunits. The binding of the interferon ligands activates the receptors, which in turn brings closer the receptor-associated kinases called TYK2 and JAK1. The kinases get activated through autophosphorylation and then phosphorylate STAT1 and STAT2 later. Phosphorylated STAT proteins together with IRF9, form a trimeric complex, which goes into the nucleus to initiate the transcription cascade of hundreds of interferon-stimulated genes, the so-called ISGs. These ISGs play diverse roles in regulating cell survival, proliferation, and death, restricting pathogen growth, modifying the innate and adaptive immune systems. In the later stage of interferon signaling, one ISG called USP18, together with STAT2, forms a dimer to displace JAK1 kinase from the receptor, thus effectively turning off the signaling cascade. As described just now, there are multiple layers in interferon production and signaling, which means a tight regulation must be adopted to avoid dysregulated signaling. Through real-world patient cases, we have learned that such regulation window is very narrow. In the case of too little interferon activity, life-threatening viral disease can arise, and it is usually viral encephalitis or severe lung infection. There can be three scenarios leading to too little interferon activity. First, a defective interferon-producing pathway, like EphA1 deficiency. EphA1 encodes MDA5, which senses RNA. Patients with EphA1 deficiency can have severe viral respiratory disease or enteroviral encephalitis. Then there could be autoantibodies in the blood to neutralize the interferon molecules like interferon alpha or interferon omega. In this case, patients can develop critical COVID. Finally, an impaired interferon signaling pathway will result in significantly less amount of ISGs produced. if at all. Patients can also develop severe COVID or influenza pneumonia. Now you might think, if interferon is so good at fighting pathogens, we should just have lots and lots of interferon. This way, we will never get an infection. And it turns out, too much interferon is also destructive to the human body, because interferon signaling initiates expression of hundreds of ISGs, which play diverse roles in numerous signaling pathways, including inflammatory pathways. Too much interferon will lead to uncontrolled autoinflammation in a group of rare diseases called type 1 interferonopathies. For example, when there is too much interferon produced in TREX1 deficiency, where aberrant DNA species accumulate, patients can have a rare but devastating disorder called Aicardi-Gouttiere syndrome, whose common features include intracranial calcification, systemic autoinflammation involving multiple organs, and severe developmental delay affecting both physical and intellectual abilities. Next aspect will be a hyperactive interferon signaling pathway per se. In STAT1 gain of function, patients can have different manifestations, including autoimmune diseases or a serious skin presentation from a fungal infection. Finally, in the case of a failed negative feedback regulation, USP18 deficiency is possibly the most severe type 1 interferonopathy. Patients often die before birth due to massive uncontrolled inflammation. Taken together, we have learned today that interferon signaling is a multi-step pathway involving different layers of regulation, and too little or too much interferon activity is detrimental to the human body, leading to either severe viral diseases or uncontrolled autoinflammatory diseases called type 1 interferonopathies.